Factoring is a huge component to a lot of what we do from here on out, as well as a huge basis to what we have next year. Factoring should also be a review topic. Factoring is something I know you did intense amounts in Algebra 1. So if you are struggling with factoring, you need to make sure that you are practicing. You are getting in for help, because there is no getting around that if you can't factor, this is going to be an extremely difficult year and next year for you. So you need to make sure that the notes that we take now are review notes. They are things to get everyone back on the page and same page and the idea of what factoring is. But we do move extensively beyond, so you need to make sure that you completely understand the basic factoring so that when we move on to higher order and grouping and stuff, that we understand this first fundamental level. When we are factoring, the general form that we are in is ax squared plus minus bx plus minus c, where a, b, and c are integers. That means there's no fractions. And a is positive. Now it can't be 0, because if it was 0, there would be no x squared. If there's no x squared, there's no factoring. And we need to make sure that there are no fractions as well. We do have a way of factoring two terms. If it is two terms, it's called a binomial. We can do three terms. Three terms is a trinomial. And we can do more terms, and anything more than that we just call a polynomial. Binomial, trinomial, and then anything else is just called a polynomial. Bi means two, so that's why it goes with two terms. Tri means three, and poly means many. Generally, our most common is going to be the highest power of 2. However, we are going to start moving to where things are going to not be 2's anymore. For the majority, though, of this stuff that we do, we stay within highest power of 2 and 3. The 2 that we're looking at right now is called a quadratic. And that is a term that we need to get quite familiar with for this chapter, a quadratic. All right, so let's start with if we're factoring a binomial. When we are factoring a binomial, we are always looking for a GCF. GCF, greatest common factor, we should know that, is the very first thing that we always need to do, and it's usually the very first thing that we forget to do. So we always want to look, does it have a greatest common factor? If it's so, we need to factor it out. If that has a common factor, you need to factor it out. Now we're going to go through just the notes part of this, and then I'm going to do several examples at the end that I'm going to work out for you so you can practice these concepts. But right now we're just going to go through the rules, the process, and the steps. When we factor out a GCF, we pull the GCF out in front, and whatever's left over goes behind. So that if I were to distribute the GCF, I would have gotten my original two-term binomial. If there is no GCF, then it needs to be a difference of two squares. It is a very specific binomial. You either have GCFs and or difference of two squares. If it doesn't fall under these categories, you cannot factor a two-term polynomial. All right, so here's a couple of examples relating to that. These are difference of two squares. difference means subtract. First one's a perfect square, second one's a perfect square. Difference of two squares. Perfect square, perfect square. This one is not. This one cannot be factored. It is not a difference. It is two squares, and that's okay. But an addition we cannot do. So star this, highlight it, cannot do it, cannot factor it, cannot be done. It is not a difference of two squares. And when we factor these difference of two squares, these two red ones here, we're going to always factor them the same way. And the way that we do that is we have our two parentheses. The first square goes in front, so this would be an XX, this would be a 2y, 2y. So XX, 2y, 2y, those go in the first spots. The signs are always opposites. And then the square of the last. So for the first one, that would be 11, 11. And for the last one, it would be 7, 7. First squares, opposite signs, second squares. And the difference of squares is always, always done that way. All right. After we factor, we always look to see, can we factor farther? Once you have factored, you always consider the possibility that you can factor farther. All right, so that's factoring a binomial. If for a binomial, you have one of two options, your GCF or your difference of two squares. If you are a GCF, factor that out and look, can you factor farther? If you're a difference of two squares, factor them a piece and see if you can go farther. And sometimes you can, and we'll look at some of those in a little bit. All right, so let's look at a trinomial, the three terms. All right, no matter how many terms we have, the very first thing we always, always, always do is we look for GCF. Like I said, it's the first thing we do, but it's the first thing we forget to do. Always consider there's a GCF. If there's a GCF, we always factor it out. The GCF goes in front, the leftover goes in back, and you always consider, can I factor farther? Can the leftovers still be factored? If it can't, fine, you're done. But if it can, you need to. All right, next part. If there is no GCF and that A is 1, what that A is that's the leading coefficient of our general form. If A is 1, we do something different than when A is not 1. So, if A is 1, we make our parentheses, we split our variable, and then we find all the factors of C that would allow us to add or subtract to be the B. Okay. If there's no GCF and A is not 1, option number 1, and there are two options here. The first option is trial and error. Now, I'm going to give you an option 2 that I am going to require you to follow, but this option number 1 is actually going to be the one that we use the most after we get very confident in option number 2. Option number 1 will be the way that we proceed in chapter 6, 7, 8, 9, 10, and next year in pre-calc. However, as we're getting used to this stuff, this factoring again, we are going to be focusing on option number 2, which is called the bottoms-up method. The bottoms-up method is an exact method. It is something that you will have to show me that you can do. And then after you show me that you can do it, then you'll be able to just factor with your trial and error. But you have to make sure, I have to make sure that you can understand how things go together first before we just try something and try something else, keep going over and over again for trial and error. All right. So the very first thing we're going to do is we're going to multiply the a to the c. That's the leading coefficient to the constant. Again, I'm giving you steps, and then we're going to apply it to problems, so that it would look something like this. We take that a out of the front, and we multiply it to whatever that c is, that constant is in the back. Now we're going to factor just like we would when a is 1. Meaning, what multiplies to be that new c, and also adds, subtracts to be the middle term, b. Once I multiply over, and I've now factored, I have to do this third step, which is the most forgotten step. This factoring is not the factoring of my original problem, because my original had an a. But when I factored, I got rid of the a. Therefore, this factoring is without that a, because x times x is how I get that x squared. So in order to fix that, or to reverse that, I must divide the original a out of the last term. So whatever numbers I came up with here, these are the numbers that multiplied together to be the new c, and then they added, subtracted to be the b. I must divide them by that a in my original a that I multiplied with. Once I divide that, this number in a is either a whole number or it needs to be reduced, because it will be a fraction. If it becomes a whole number, yay, we're done. But if it is a fraction, we're going to move the bottom, which is called the denominator, up to the coefficient of x. We're going to take the denominator, whatever that reduced denominator is, and we're going to do bottom up, and we're going to put it in front of the coefficient. All right, so like I said, this is all just the notes. We're going to apply it to actual problems so that you can practice it. But these are just the steps. So let's look at examples. All right. And there's about 12 examples here. So we're going to get lots of practice in our notes here on factoring. (3x squared minus 9x) This is a binomial. So a binomial, we always start with, is there GCF? Is there something in common with my two terms? And we should recognize that there is a 3x in common. That's my GCF. And when I pull it out, left over is going to be an x minus 3. Now when I look at this, I need to consider, can I factor 3x farther? No. And can I factor x minus 3 farther? No. In order to factor, you have to have powers. So if I don't have any powers, I can't do any more factoring. Okay. Example number 2. (5x squared minus 25). First thing is a GCF. What is in common with 5x squared and 25? We should see the 5. And when I take out the 5, left over is x squared minus 5. Again, if I were to distribute this, I would get my original problem back. That's how I know I factored correctly. And when I look in here, I do have a power, but this is not a difference of 2 squares because it is 2 terms. There's no more GCF. So the other option is difference of 2 squares. I do have a difference. I do have 1 square, but I don't have 2 of them. So this is the farthest I can go. (25x squared minus 81). 25 and 81 share nothing. They don't have a common factor. So I need to ask myself, is this a difference of 2 squares? And we should recognize these are perfect squares. It is 5x and 9, 5x opposite sign, and 9. Go back to your notes if you need to check that. The first square goes in the first spot, the second square goes in the second spot, and they're opposite signs. It doesn't matter plus, minus, minus, plus. As long as they are opposite, we are good. (2x squared minus 2). First, we always look for a GCF, and there is a common factor here. The common factor between those is 2, so I'm going to pull out a 2. Left over will be x squared minus 1. Now when I look at this, I do have a power. I need to consider that that power can still be factored. Well, if it's a binomial, it's either GCF or difference of 2 squares. Well, there's nothing else in common, so it's not GCF. But I do have difference. This is a square, and 1 is a perfect square. So this can be factored as difference of 2 squares. X squared is x and x. 1 is 1 and 1 with opposite signs. That is my final solution. All right, let's go to 3 terms. X squared plus 2x plus 1. My leading coefficient is a 1, so I'm going to follow that first method. First method is, the one we always forget, is there a GCF? There's nothing in common, so there is no GCF. So we're going to go to step or letter B of the factoring 3 terms if you refer back to your notes, where there is no GCF and the A is 1. We're going to make 2 parentheses. We're going to split our letter. And then we're going to say what multiplies to be C. Here's C. This tells me it's going to add to be my B. So what multiplies to be 1 and adds to be positive 2? Well, there's only one thing that multiplies to be 1, and that's 1 and 1. And the only way they add to be positive 2 is if they're both positive. In math, whenever we have two of the exact same factors, we need to condense them into one. So you do need to rewrite this as x plus 1 squared. If you leave it this way, that's fine. You'll get, 1 point. But if you forget to go farther, you would lose another point. So please make sure that if you have double factors, that you combine them as far as possible. All right, so here we have x squared minus 5x minus 24. There's no GCF because there's nothing in common everywhere. So that means I'm going to make my two parentheses. I'm going to split my letter. And then I'm going to ask the question, what multiplies to be 24? This sign tells me they're subtracting to be negative 5. Well, first of all, now this is not something you need to write down. I'm just doing it for your kind of note purposes. Make sure everyone's on the same page. What multiplies to be 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. Of those, which ones subtract to be negative 5? Well, 1 and 24 subtract to be 23. 2 and 12 subtract to be 10. 3 and 8 subtract to be 5. But they only subtract to be 5 if the 8 is positive or is negative and the 3 is positive. If you're unsure, check it. And checking is something you're going to have to get very comfortable with doing, especially when we move out of our bottoms-up method and we get into trial and error. You need to be able to check that negative 8 plus 3 is negative 5. That's your factoring. X squared minus 6x minus 3. No GCF. There's nothing in common. So parentheses, split the letter. And then what multiplies to be 3? Well, the only thing that multiplies to be 3 is 1 and 3. 1 and 3 will never subtract to be 6. So if something cannot be factored, we call it prime. It is not factorable. And those are possible problems that you will encounter. Okay, so we've done binomials, we've done trinomials with a leading coefficient of 1. So let's go to a leading coefficient of not 1. First thing we need to consider is there a GCF? Is there something in common with the 2, the 1, and the 3? And the answer is no, there's not. So now we're going to go through our bottoms-up method. The bottoms-up method says we're going to take our A and multiply it to C. So I get x squared minus x minus 6. Multiply A to C. Then we get to factor just like we did up here. Two parentheses, split the variable. What multiplies to be 6? 1 and 6, 2 and 3. And subtracts to be negative 1. Well, 2 and 3 will give me negative 1. But only if the 3 is negative and the 2 is positive. It does not matter if I put the plus 2 in the second parenthesis or the negative 3 in the first. As long as the 2 is positive and the 3 is negative, it does not matter where I put that piece of information. All right, so this is where we start into the bottoms-up method. This is that part that we usually forget, and it is the step 3, if you go back to your notes, where it says we divide the original A, and here's my original A, into that last term. And reduce. So this gives me an x plus 1, because 2 divided by 2 is 1. And this gives me 3 halves, because 3 halves does not reduce. Part 5, if it's a whole number, we're done. Yay, that's done. But if there is a denominator, the bottom up. So 2x minus 3. And you can check it. See if it works. X and 2x is 2x squared. Then we have minus 3x plus 2x. Well, that's our minus x. And then 1 and negative 3 is negative 3. There's our bottoms up. All right, let's try it again. First thing we want to do is look for GCF for 19.5 share nothing. So I'm going to multiply the A over to the C. Then we're going to factor as usual, parentheses, letter, what multiplies to be 20, subtracts to be negative 19, negative 20, positive 1 is what you should have come up with. Now we need to divide by the original A. The original A is 4. In this case, it's 4. Reduce if you can. If it reduces, great. But if it doesn't, bottom up. And check it. Okay, I'm going to put one more up here. And I want you to pause your video right now, and I want you to try it on your own. Yes, hit pause. Try the steps on your own. See if you can do it. So no GCF. Multiply the 12. What multiplies to be 12? 1 and 12, 2 and 6, 3 and 4. And of those, what will give me 28? Absolutely nothing. It's prime. I know, that was tricky. Okay, we got 3 more that we need to look at. 5x squared plus 20x minus 25. All right, so now we need to consider that we have GCFs, because those last 3 we didn't. So now we're going to. What's in common with all of them is a 5. So we're going to take out the 5, take out the 5, take out the 5. Anytime I take out a greatest common factor, I need to consider the fact that I can continue factoring, especially when there is a higher power than 1 still showing. So I need to consider that this factors farther. X squared is going to break to x and x. And then I ask myself, what multiplies to be 5, subtracts to be positive 4? Well, what multiplies to be 5 is only 1 and 5. And 1 and 5 do subtract to be 4, but only if the 5 is positive and the 1 is negative. Once I'm done with that, now I'm done factoring. So there were 2 steps to this. There was the GCF factoring, and then there was our parenthesis factoring. You need to always consider you can go farther. Okay? (25 minus 36a squared). Now, this is written backwards from our normal, but that's okay. We would want to have our a squared positive and first. If I were to rewrite this, my a squared would not be positive. It would be negative. And we don't like that. We don't like our a squareds to be negative. So if you can rewrite and your square is positive, then rewrite it. But if you cannot switch these around because your square would be negative, leave it alone. There's no GCF, so we consider difference of 2 squares. 25 is 5 and 5. Difference of 2 squares always have opposite signs. And then 36a is going to be 6a. So let's look at one that's backwards again. 30 plus v minus v squared. Now again, if I look here, the square is negative. So I don't want to rewrite this. I do not want to put negative v squared plus v plus 30. I do not like to have my squares, my leading coefficient, negative. So we're going to kind of work backwards. We're going to look at this being our a over here, even though we generally go a, b, c. So our leading coefficient is 1. There is no GCFs. So I'm going to split v. What's going to multiply to be 30? And here's my sign out here side of 30. But because of this minus sign, this minus tells me I'm actually opposite signs. Because that's the only way, if I check this, minus v plus v, I can get a negative v squared. So I am, even though this is a plus, I am subtracting. What's going to multiply to be 30 and subtract to be positive 1? Well, it's going to be 5 and 6. Hopefully we get that would be 5 and 6. But when I check it, I need this to be positive and that to be negative, so that I get a positive 1. Or the 6 is positive, so I get the positive 1. So that means the 6 is going to go here. The v with the negative gets the 5. You need to make sure you check. Does it work? Does it make sense? Alright, so that's a whole lot of practicing of factoring, and we're going to do a whole bunch more in class.